A battle for the future of American stargazing is about to begin, and the stakes are sky high. Ask astronomers what question they most want to answer, and you will get scattered responses. How did the first stars, galaxies, and black holes form? What is the nature of dark matter and dark energy? Are we alone? Each question demands its own large telescope. No ultimate, one-size-fits-all instrument will ever exist, for none can be made to gather each and every kind of cosmic light. Black holes sometimes shine in X-rays, for instance, whereas Earth-like exoplanets are best studied in optical and infrared light. Yet such projects so strain the fraction of public and private funds allocated to astronomy that only a few, perhaps just one, can be prioritized at a time, leading to pileups of also-ran proposals and anxious researchers awaiting a rare chance to open new windows on the universe. In the U.S., astronomers have managed these competing ambitions by devising a process that has become the envy of the scientific world, the Astronomy and Astrophysics Decadal Survey, a once-in-10 years exercise that recommends and ranks the community's priorities for the next decade, embodied, eventually, by major new federally sponsored observatories on the ground and in space. Projects such as NASA's Hubble Space Telescope owe their existence, in part, to coveted endorsements from decadals of yore, and the practice has spread to several other disciplines that now undertake decadal surveys of their own. Organized by the National Academies of Sciences, Engineering, and Medicine, 6 decadal surveys have set the course of U.S. astronomy since they began in the 1960s. The results of the 7th, dubbed Astro 2020, will soon be announced after 2 years of exhaustive deliberations led by a 20-member steering committee. And just like its predecessors, Astro 2020 will reveal where major new investments and discoveries are most likely to be made, and where neglect, disinterest, or even fear may block progress for generations to come. Few people know the power of these surveys better than Joel Perriott. More than 20 years ago, he got his start in federal politics as a staffer at the National Academies, where his initial assignment was to assist the scientists crafting the first astronomy decadal of the new millennium. Then he served a 10-year stint in the White House Office of Management and Budget, OMB, where he weighed and implemented decadal recommendations for federal science agencies. Today he is Director of Public Policy at the American Astronomical Society, the leading advocacy group for U.S. stargazers. At the OMB, where the nation's policy objectives often brutally intersect with its fiscal realities, the decadal survey offered Perriott and his colleagues a foolproof way of dismissing overly solicitous astronomers. If a project wasn't highly ranked, we knew it didn't have the community's endorsement, he says. That's really helpful for folks on Capitol Hill and in the White House who need to make hard choices. For more than a few astronomers, a drab name like the decadal does not properly capture a process that holds such sway over their destiny. Instead, they sometimes just call it the voice of God. In coming weeks, when Astro 2020's final report is released, that voice, that supposedly communal voice, will once again speak. Yet outside of a chosen few, sworn to secrecy, no one in the community knows in advance what it will say. Everyone, though, agrees Astro 2020's conclusions arrive at a time of peril. We are right now on a knife edge, says John O'Mara, chief scientist of the W.M. Keck Observatory on Mauna Kea in Hawaii. I do believe this decadal is existential for astronomy in the United States. When you consider the facilities and the science topics that are under discussion, it will influence whether or not we become a second-place player in global astronomy. When the federal agencies and Congress receive the decadal report, they will hold in their hands the decision of whether or not we wish to have leadership in this field of science. U.S. telescopes in twilight. From the outside looking in, one would not realize the enterprise of U.S. astronomy is teetering on the edge of crisis. Several new ground-based telescopes have recently come online, each bringing a bumper crop of celestial discoveries, and even more ambitious projects are waiting in the wings. Consider the Vera C. Rubin Observatory, a high-ranked priority of the past 2 decadals, which are naturally called Astro 2000 and Astro 2010. Sited on a mountain in Chile, the Rubin Observatory should begin operations in late 2023 to generate a high-definition, decade-spanning time-lapse movie of the entire overhead sky. But among large upcoming U.S. projects, Rubin is a rare, healthy exception. The other highest-profile ground-based recommendation from Astro 2000 and Astro 2010, building an optical extremely large telescope, ELT, with a mirror circa 30 meters in size, remains in limbo. One selling point for ELTs, among many, is that they offer the best hopes of ever studying Earth-like exoplanets from the ground. Astro 2020 will probably decide if the U.S. ELT efforts sink or swim, or if other projects, such as a next-generation upgrade to the nation's very large array of radio telescopes or expansions of gravitational wave observatories, take priority. In the quest for an ELT, the US has managed to produce two competing projects, the 30-meter telescope, TMT, and the Giant Magellan Telescope, GMT. Both are short on funding, and neither appears likely to begin operations before the decade is out, each having served to stifle the other. And the TMT's early stages of construction on the Hawaiian volcano Mauna Kea, a site unrivaled for pristine views of the northern hemisphere sky, sparked protests from activists who see telescopes there as an occupying affront to the mountain, which native Hawaiians hold sacred. Construction on the TMT ceased after protesters repeatedly blocked the road to the mountaintop. The conflict remains at an impasse. If Astro 2020 says, forget the ELTs, let's prioritize something else instead, then it's quite possible that both the TMT and the GMT will die, says a senior ground-based astronomer familiar with the situation. Europe, in contrast, took the lead over the US in ground-based optical astronomy years ago and is well into construction of an ELT of its own in Chile. The European Extremely Large Telescope boasts a 40-meter mirror, and it is projected to come online in 2027. China is surging ahead as well. For evidence, look no further than the US's iconic National Science Foundation-funded Arecibo Radio Telescope in Puerto Rico. Once the world's largest, the radio telescope catastrophically collapsed last year in part because of budgetary neglect, but not before China's 500-meter aperture spherical radio telescope, FAST, had superseded it in size. And together, without the US, Europe, China and many other international partners are building the Square Kilometer Array, SKA, a breathtakingly powerful collection of thousands of radio telescopes that is set to become fully operational at sites in Australia and South Africa as early as 2030. The Hungry Giant and Frankenstein's Monster. The outlook is similarly mixed for the nation's space-based astronomy. For now, the US remains at the forefront of off-world observing, but of the four great observatories NASA launched between 1990 and 2003, only Hubble and the Chandra X-ray Observatory are still operational, and both are nearing their end, with no replacement on the horizon. Hubble is probably not going to last another decade, and maybe we'll get 5 more years out of Chandra. But then that's it, they're gone, says Jason Tumlinson, an astronomer heading the Community Missions Office at the Space Telescope Science Institute. We'll probably have a long gap with no real optical, ultraviolet or X-ray capability in space. And now is the time to decide how and when we might get it back. Technicians examine the James Webb Space Telescope in preparation for its launch. Technicians examine the 6.5-meter segmented primary mirror and deployable sunshield of the James Webb Space Telescope, NASA's $10 billion flagship observatory, which is scheduled to launch in November. Credit, Chris Gunn, NASA. Astro 2000's top-ranked space project, NASA's flagship-class James Webb Space Telescope, is a technological marvel, a cryogenically cooled infrared observatory with a segmented, 6.5-meter starlight gathering mirror that folds, origami-like, to fit in a rocket. Early on, Webb was projected to cost about $1.5 billion and to launch perhaps in 2011 to study the emergence of stars and galaxies in the early universe. Today those projections seem hopelessly naive. After a staggering number of cost overruns and delays that hobbled planning for other projects, the current best-case scenario is that the telescope will reach space no sooner than this mid-November, operating for just a decade with a total project cost of about $10 billion. Less optimal scenarios, of which there are many, are almost too grim to contemplate. We can't do science at this scale without taking risks, and I'm confident in our chances of success, but if Webb fails, it will be an unmitigated disaster, says Matt Mountain, the project's telescope scientist and president of the Association of Universities for Research in Astronomy. It has to work. Because if it doesn't, we aren't going to do another ambitious flagship for, I would guess, 2 decades. If Webb was a hungry giant unleashed by Astro 2000 and its antecedents biting off more than could be chewed, then the top flagship recommendation of Astro 2010, NASA's Nancy Grace Roman Space Telescope, was a different beast entirely, a cut-rate Frankenstein's monster the Decadal Committee pieced together from the dismembered remains of multiple competing mission concepts. The committee had hoped to avoid another Webb-style debacle with Roman, initially named the Wide Field Infrared Survey Telescope, or WIFIRST, and it did. But instead Roman's very existence threatened to tear the community apart from within. Do you know what WIFIRST really stood for most of us? Says one leading astronomer. It stood for what the fuck is this ridiculous space telescope? Originally envisioned to study dark energy with a bare-bones instrument package and a mirror scarcely half the size of Hubble's, Roman was projected to launch as early as 2020 on a relatively slim budget of less than $2 billion. To many expert eyes, such a project barely qualified for its supposed flagship status. NASA, with bipartisan congressional blessings, ultimately added more instruments and upgraded Roman's mirror to the same size as Hubble's, enhancing its science objectives and assuaging many criticisms, but also nearly doubling its estimated price tag and delaying its launch to no earlier than 2025. Meanwhile, Europe and China have each proceeded with dark energy-focused space telescopes of their own, potentially scooping some of the promised scientific discoveries used to justify Roman's existence in the first place. The primary mirror of the Nancy Grace Roman Space Telescope. View of the 2.4-meter primary mirror of NASA's Nancy Grace Roman Space Telescope, the next flagship observatory to fly after Webb. Credit, LaHarris Technologies Incorporated. Although both Webb and Roman may each eventually succeed beyond astronomers' wildest imaginings, some fear the project's greatest initial impact on the field will be to sharply curtail Astro 2020's ability to plan for a prosperous future. This is, I think, the first decadal where both of the top space-based recommendations from the previous two decadals, Webb and Roman, were still on the ground, Tumlinson says. And if the Astro 2020 committee were to say, "We've got two flagships stacked up, the queue is too long, let's just pause for a while and do some smaller missions and catch up later," that would be a mistake. The idea that you can just take a decade off from ambitious things to come back and do them later is not valid when you consider how our government actually works. Most astronomers, Tumlinson says, seem to misunderstand what the decadal's governing dynamic actually is. A decadal report is the beginning of a multi-party, multi-year negotiation between the scientific community, NASA, the aerospace contractors, Congress and the White House, he explains, which is why aiming high at the outset is in astronomers' best interest. I would hope, with Astro 2020, we temper our natural desire to mitigate risk and cut costs, Tumlinson says, because all the other forces in this system will be doing that for us anyway. Whether because of the COVID-19 pandemic, soaring deficit spending or the increasingly dire global climate emergency, some might question the wisdom of U.S. astronomers reaching for the stars just as the sky seems set to fall. Then again, the reply comes, where is the wisdom in limiting the science of the 2040s or 2050s based on the troubles of the 2020s? At the end of the day, appropriators are still going to spend money, says a former congressional staffer who dealt with high-level appropriations for federal science agencies. They're going to get an allocation, and their job will be to use it wisely. If it doesn't go to astronomy, maybe it will go to a new flagship mission for NASA's Planetary Science Division instead, or maybe it will go to a new FBI building. But that money will be spent, regardless of what astronomers do. Artists' impression of the major optical elements for 4 next-generation flagship concepts. Artists' impression of the major optical elements for 4 next-generation flagship concepts under evaluation by Astro 2020. Clockwise from bottom left, they are the Habitable Exoplanet Observatory, HAB-X, the Large Ultraviolet Optical Infrared Surveyor, LUVOIR, the Origins Space Telescope and the Lynx X-ray Observatory. Credit, G. Tremblay and the new great observatories. The main menu. Responding to the woes from Webb and Roman, years ago NASA began revamping its approach to future flagships, demanding greater certainty about technological challenges and costs. In 2016, the agency assembled 4 Science and Technology Definition Teams, STDTs, each examining a separate mission concept for Astro 2020's Consider It.